Aloha and welcome back to another micro lesson. This time we're talking about exponential functions. So if you open up your notes to page 10, you'll see a whole bunch of mumbo jumbo that looks quite atrocious, but we're going to break it down and hopefully make sense of it by the end of this video. So when we look at this, we got graphing y equals ab to the x when b is greater than 1. So first of all, this is a times b. They are separated by a multiplication. It's not written, it's assumed. X is in the exponential function. So like in our last video we talked about, anytime your variable is up in the exponent, that's called an exponential function. Yippee. And a is kind of like your amplifier. It's how quickly and how tall your graph grows, either up or down. B is your base, and that's going to be the most important part. That's what we're going to be kind of focusing on. X is your variable. That's going to be your inputs, what you're plugging in, what values. And then sometimes you'll see something extra like a plus C on the outside. So, and what that does is it moves your graph up and down. So what I'm going to do is I'm going to hop over to Desmos in just a minute after I talk about these. The other one over here is a different graph where B is bigger than 0 and at the same time less than 1. That means it's between 0 and 1. And if it's between 0 and 1, that's essentially a fraction, right? Like 1/2, 1/3, 0.783. And depending on what your base is, between 0 and 1, it's going to kind of come down and level off, or it's going to go up and then level off. If your b is greater than 1, that means it's going to blow up as you move to the right. So it's starting level and then either blows up or down depending on what your a value is. So we have all these different variables at play. Well, let's take a quick look and see what we can see. So if you guys go and open up Desmos, open up the graphing calculator, and I just want you to type this in as you see it. So I got y equals a times b to the x, and then you have to hit the down arrow and plus c. So I'm going to do that. Y equals a times b, and then you hit shift 6 is what most of them are to get up in the exponent position. Otherwise there is a little calculator drop down so you can hit up power. Get out of here. And then go down and then press plus C. So what we can do is we can add a whole bunch of different things called sliders. And these sliders are going to basically fill in values for A, B, and C. So right now A, B, and C are all set to be 1. And our variable is X, and that's our input, and our output is Y. So here we mentioned what happens if it's bigger than 1 or if it's between 0 and 1, but we didn't mention what happens if it is 1. If it is 1, it's just boring. That's like 1 to the second power, 1 to the third power. Well, 1 to the second is 1 times 1, which is 1. 1 to the third is 1 times 1 times 1, which is 1. 1 to the eighth is 1 times 1 times 1, 1. That's 1, right? So that's boring. So everything is just a 1 when you come out here. So what happens is if b is bigger than 1, what you see right away is that this graph is blowing up and it's going to the right, which is exactly what our graph says on our notes. And if b goes negative, between 0 and 1, you see that our graph kind of blows up to the left. So it's coming down and getting smaller. We always try to read graphs from left to right. So here it's coming down as you go to the right, and then it's going to be leveling off. Now we didn't say what happens when b is less than 0. We will come to that in a second. But those are the first things you want to look at is your base. If your base is between 0 and 1, it's coming down and leveling off. If your base is bigger than 1, it's blown up to the right. A, sometimes you'll have a number in front. A is more of like an amplifier. So if I keep B at 1.7 and I raise A up, it just makes the graph taller faster. And if I get close to 0 and then go down below 0, it flips the graph upside down. And that's exactly what our notes are telling us. If A is negative, the graph opens downward. If A is positive, it opens upward. When it's between 0 and 1, it's above, and when it's negative, it turns down. So you can open up Desmos and you can kind of mess around with this and just kind of get used to all the different scenarios. And then C here, again, I mentioned it is just a raising and a lowering of your graph. So that's literally all it does, moves it up and down. Okie dokie. Something that I want to show you then after now is what happens when it gets to 0. So as you get closer and closer and closer and closer, when you get to 0, you're missing a lot of the graph. This is when things get funky. So before I go any further, what I'm going to do is I'm going to duplicate this graph and then make one of them into a table. And then I'm going to add some more values. I'm going to add -3, -4. I'm going to add +3, +4. And then let's see what happens when you go down. When b finally becomes negative, you get a scattered. Notice how there's no longer a line that's connecting these things. That's because it's completely disjoint. And as you keep going, you see some funkiness. It looks like, whoa. And then it kind of blows up like that. So it's flipping back and forth between a positive and a negative value. And this is kind of what the table is showing you. Positive, negative, positive, positive, negative. And that's what's going on. So we don't care about what happens when it's less than 0. It's not a defined function for us. And we're focusing on only continuous defined functions. Here, the red line comes back in, and it is all good. Every point in between here is a point on this function. When you're less than 0, you get just a breakup of points. I hope that makes sense. So the other thing Desmos is cool for is you can always go here and check your answer. I'm going to turn these graphs off. For example, if you look back on page 10, your first problem that you have to solve is y equals 3 to the x minus 5. So Desmos can do that for you, and this is what your graph should look like. So when you get down to it, use Desmos to check your answers out. And if you want to, you can click this cogwheel button, and again, what that does is it allows you to, I can duplicate it. I like to do that just so I keep 2 copies of it, and then you can go, one of those buttons was to open up a table. So these are the values that you should get. However, you can't use your Desmos on your exam. You're going to have to do everything on your calculator. So make sure you know how to use your calculator. Calculators can be quite tricky, especially if you have the XA. But most calculators, you will have like an X to the Y button like this. So for example, if you wanted to do 3 raised to the -2nd power, some of them you have to do negative sign second, some of them you have to do the negative sign first. You can click go, and then you got to subtract 5, -5, bam, and we get exactly what we match up with. So if you need help with calculator, let me know. If you are good to go, then that is awesome. Good job. This will conclude this. The only thing I want you to do is complete that graph and do the graphs on page 11. If you have any questions, let me know. Thank you.